Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic we're going to describe the equality of vectors. So we will define when two vectors are equal, when they are unequal, and we will look at the properties of equality. Now, two n-dimensional real vectors are said to be equal if each of their corresponding entries are equal as real numbers. That is, two vectors u and v, elements in r to the n, are equal, and we'll write this as u equals v, if and only if the first entries are equal, the second entries are equal, and so on and so forth, including up until the nth entries. So, for example, here are two three-dimensional vectors, and even though one is written as rational numbers and the other as floating point numbers, these two vectors are equal because each of the three entries are equal. So, even if vectors differ in a single entry, they are considered to be unequal. So, for example, these two vectors are unequal because the third entries are not the same. 0.93 is not equal to 0.98. Both of these two four-dimensional vectors have the same entries, but they occur in different locations. And so because the third and fourth entries are not equal, these two vectors are considered to be unequal. Now, in some cases, two vectors may be close enough. But again, to precisely define close enough, we need to be able to calculate the distance between two vectors, and we will see that in a future topic. So, for example, here are two vectors. They are definitely not equal, but at least their first 4 or 5 digits are equal in every single entry. So we may consider, under certain circumstances, these two vectors to be close enough. Now, let's review some of the properties of equality. First of all, every vector must be equal to itself, and this is the reflexive property of equality. If u is equal to v, then v is equal to u. This is the symmetry property. And notice that not all relations are symmetric. For example, 4 is less than 5 does not mean that 5 is less than 4. So the symmetry property is significant, and not all relations have this property. On the other hand, equality is also transitive. If u is equal to v and v is equal to w, then u must also equal w. Now, you'll notice that with the less than relationship is also transitive. If x is less than y and y is less than z, then x is less than z as well. So, it's not that all operators or all relations have or do not have all the same properties. Equality is reflexive, symmetric, and transitive. There's also one more property of equality. If u is equal to v as vectors, then any statement about u is true for v and vice versa. Now, note, we are not going to compare vectors that do not have the same dimension. It's like comparing apples and oranges. We are going to be focusing on vectors within one dimension at the same time. Either we're dealing with 7-dimensional vectors, or we're dealing with 5-dimensional vectors, or 1,000,000-dimensional vectors. But we're not going to be comparing 3-dimensional and 7-dimensional vectors. So, following this topic, you now understand the concept of vector equality. You understand that we will not be comparing vectors of different dimensions, and you've been exposed to the properties of equality: reflexivity, symmetry, and transitivity. Also, if two vectors are equal, then any question that is true or any statement true about one is also true about the other. Here are the references, acknowledgements, the colophon, and a disclaimer. Cheers!